Assalamu alaikum and a very good evening to all of you. I thank you all for joining today's webinar. This is the fifth webinar organized by ReForm that aims to disseminate knowledge on crucial topics by distinguished faculties and practitioners from the respective field across the globe. We at ReForm aim to give Bangladesh a new scholarly face that the world values. Our mission is to bring researchers together through knowledge sharing and to innovate and enhance the productivity and technological advancement of Bangladesh. The title for today's presentation is an adaptation assessment framework for runtime security assurance case evaluation. And our today's speaker is Dr. Sharmin Jahan. A little bit about her. She is currently working as a tenure track assistant professor in the Department of Computer Science at Oklahoma State University. She has completed her PhD in computer science from University of Tulsa. Her research interest is in information security, self-protecting systems, and secure service mesh. Today's talk focuses on dynamic security assurance for autonomous system, also known as self-adaptive system SAS. This research aims to embed security awareness by interpreting dynamic operational environment with potential uncertainty using explainable AI models and enable autonomous decision-making ability within SAS to assure its optimal security, compliance, confidence. To present and organize a organized webinar, I would like to request all the participants to mute their microphones. A question and answer session will be held after the talk, and I would like to request Dr. Sharmin Jahan to present her speech. The floor is all yours.
Thank you, Mahdi. And thank you everyone for attending today's seminar and give me the chance to present my work in this platform. So I start. So autonomous systems, like in this current era, we are actually moving forward to more getting involved to use more autonomous systems in our day-to-day life, like smart watch, smart thermostat, and we all kind of right now know about the future of self-driving car. Even like autonomous systems is very popular using for the medical healthcare service and like the continuous monitoring the critical patients and then provide the emergency services to the chronical patients who has chronic disease and also even autonomous systems is involved in warehouse management. It's just some examples. It's not only the applications are not limited to this field, like it is overly gaining popularity in our day-to-day life. So what is autonomous systems? As per wiki, the definition is it is a connected group of some devices. They are connected through some network protocols, and usually it is managed by a single administrative, but now it can then multiple vendors can work together and then provide the services to the and build a big enterprise product for the business operations. So autonomous systems is actually when it was first proposed, it has the visions and then and mostly it was developed for mission critical situations where inhuman involvement is problematic, in the where situations we need to deploy the unmanned aerial systems to for tracking the terrain or and also that spying on the enemy side, and that type of missions it was actually initially it was developed, but now it is gaining popularity and getting into our regular life. So it is anticipated that in the near future, the market value will be increased, and then within this next 2-3 years, the market value will be the 20 times higher than the current situations. But there is a difference between the autonomous systems and self-adaptive systems. Like autonomous systems can be rule-based, but self-adaptive systems is more resilient and kind of more capable to handle uncertain situations. Because like, think about the situations like autonomous systems are now deploying in the open environment, and multiple agents are involved in this, and also factors are involved in this environment. So the situation is kind of uncertain. We cannot predict all possible situations will happen in future. So that's why like it should be more intelligent and more capable to figure it out what's going on around it, and then make the decision by itself. So self-adaptive systems gives the autonomous systems some special capability. Mostly these four are also like kind of example, but like it has other capabilities. So the more popular capabilities are like the self-configuring, like if any, it can reconfigure itself to like without or little human interventions to like that, to handle the uncertain situations. Like for example, like for one of the component may be broke or something, and it cannot continue its operation. So in that case, like it can enable the backup systems and everything all by itself. And self-optimizations, and it can or like optimize its performance and like that configure its components accordingly to optimize its performance. Like for example, like for web server application, web applications, sometimes like when the web request or like the traffic is so high, instead of applying one, like involving one server, it can involve multiple servers to optimize its performance. Self-healing also, like it adapt to adjust the faulty components. And self-protecting, that is mostly my research focus. Like when the system speaks that feel that like someone is trying to manipulate it, or the or have some like the chance to have the malicious attacks, it will enable the defense mechanisms all by itself accordingly as per the attack type and to protect itself. But in an umbrella term, we can call these types of systems which can make its own decisions all by itself by assessing the uncertain conditions around itself. It's called self-adaptive systems, and it has the ability to modify its functionality to in a response to change its dynamic environment. So when we can call an autonomous systems and self-adaptive systems. As I said, that self-adaptive systems have special capability to handle some uncertain situations, and when this uncertain situation arises, like when it operates in an open environment. So like the environment change is not as per in our hand. Like that's why like it's open environment. And like as we know that like currently we are in the internet era, and we cannot manage like that control what type of what type of like the reaction comes from the other side. So when it's for this like when the autonomous systems like that operates in these types of environment, and then we need to enable the self-adaptive capability. The next characteristic to being a self-adaptive systems is context aware. So it is operating in an open environment. It cannot make decisions if it does not know what's going on around it. So it should be like that. It should have some ability to figure it out what's going on, or anticipate like that what is my operational context, and then based on this context, it will then and like the make its decision to for adjust its functionality. And obviously, like to adjust its functionality, it needs to know like what ability it has. Like when I want to like enable multiple server, for example, multiple server for enhancing like that, improving my performance, obviously I should have some backup server like that ready for me, right? So it should need the knowledge, like what should be possible for my current situations, and then based on those knowledge and like it, and also like what is my internal like the system's internal conditions, it will figure it out like that what is the most appropriate adaptations for handling these situations. And not only that, like when the systems figure it out, this could be an adaptations, but these adaptations has is not maybe good for this context. So it should also do some assessment on these adaptations conditions. And based on those conditions, then it will figure it out this is the most appropriate one. So these three characteristics we need to develop a self-adaptive systems. But there is a problem, right? We are saying that the they are operating in an open environment, and it will it has to understand its context and the development figure it out what should be the appropriate adaptations. But how can I say that this is the appropriate adaptations, right? Maybe these adaptations can and systems have different objectives also. Mostly the adaptations that type systems want to continue its operations, so it cares about its functional requirement. Functional requirements is usually what is the primary objective of the systems, what is the functionality of the systems. But when I want to continue my functionality, that time I just want to the systems may want to enable any component that could continue its operations, but maybe that component is not secure enough to continue these operations. For example, I have a that transmission protocols that requires encrypted data, and for some reasons that web server is not working or something, and then I cannot provide the encryption service. So my functionality is to transmit traffic, and that time I will find out any server that can provide that allow me to transmit service, but that is not providing my encryption service. So it may arise some security issues. So we have to even if we want to that continue our functionality, we have to figure it out the most optimal adaptations that will be that will continue my functionality as along with my security requirements. So we need some assessment capability for self-adaptive systems that can assess systems security assurance status, and then figure it out these adaptations can provide the most optimal secure situations to continue my functional requirement. But now, how? We have to include the information assurance process. So what is information assurance process? It is the process to give us the it is a methodical process to provide us the confidence value as per some risk management framework, and then it will provide the plans that how to secure informations and information systems to related to use and process, storage or transmission of information. So when I said the secure information and information systems, what does that mean? That means I have to protect those informations and then the systems integrity, availability, authenticity, and non-repudiations and confidentiality of that information, so that the classified informations are protected. And then we have to perform some risk assessment to find out that how to provide the assurance confidence that how good the adaptation could be to handle the vulnerability to handle considering the probability and impact of the threats to exploit this vulnerability. But usually information assurance process is very common that practice in software development, but that is usually perform at the testing phase and after and in the auditing phase in a periodical manner. But self-adaptive systems, it changes its functionality anytime, right? It's operates in the runtime and in the open environment, and figure it out the situation is not as per we expected, and then we have to adjust our functionality. So it's not possible that we involve a human that all 24/7 to that figure that to do the risk assessment by his human expertise. But so that's why the self-adaptive systems need some capability that dynamically change its functionality and assess process can perform assessment process can perform at runtime. But now for doing the runtime assessment, how can we do that? We need self-awareness, like how human do the self like that assessment process, because human knows about these systems. Human knows the what should be the better conditions for these situations, and based on his expertism, like they figure it out to like this could be the better solution to handle this situation. So machine also needs this awareness, machine also needs this intelligence, right? So we have to embed this awareness into the self-adaptive systems. So what does that this self-awareness like mean? We have a pre-developed methodical process that can work as the knowledge, which has the representation of the system's internal components and its what is its requirement and constants, and also have another component that has the ability to assess the impact of the environmental condition change on the systems. So self-awareness obviously need to reflect that how my systems is doing in these situations, and also then figure it out that this is my ability, and then what should be the most appropriate adaptations for these situations. And it is considered as one of the prerequisites when we want to develop self-adaptive systems. We have to have developed a self-awareness process. So my research is related to incorporating self-awareness into the systems, but I am dealing with only security requirements. That's why like we named it the security awareness, which is also another kind of self-adaptive systems. So what this self-awareness, like security awareness component provide us, like what does it provide to us, to the self-awareness? It estimated the security compliance confidence, considering the adaptations conditions, and the measure the confidence, like how good this adaptation could be to comply with the security requirements along with complying with the functional requirements. So the security requirements are actually like we extracted it from like a document defined by National Institute of Standard and Technology, that is like an organization for working for US federal systems. They define that what they design the risk management framework, and they define some security controls like which we should comply to, like that protect the information systems and then the informations. So mostly my security requirements that I was working like that was extracted from those security controls, and then like we define the we based on the like we extracted the security requirements from the security controls, and then design the security awareness process like accordingly, so that like it can figure it out like how good this adaptation could be to comply with those security controls. And as I said that like adaptations is like the decided at runtime, so it may has potential to like the degrade the compliance confidence. Like initially, like when we design the systems, we know that like this is my requirement, and we design the systems accordingly. But in the runtime environment, dynamic environment, like systems adjust itself and maybe does not know like what should be the best. That's why I said the optimal solutions, not the perfect solutions. So adaptations has the possibility to degrade the compliance confidence. So security awareness will figure out how much it has been it will degrade. So when I was working on this project, like on this research work, like we addresses that like we have 3 challenges that are associated to incorporate security awareness into self-adaptive systems. So these 3 challenges are actually I addressed, but still it has like many more other challenges. So the first challenge is like, how can we say that like we, as I said, that for security awareness, like we need the representation of the system's internal structure, and then to determine that what's the system's status, right? So we have to figure it out. There should be a way to access to and reason over the representation of its security profile. So security profile is what is my security requirements and what is my component and how they comply to like how this component are important to comply the security requirements. So we need to abstract the system's internal structure. And then adaptation changes the internal structure by adjusting its functionality, right? So this model also needs to be dynamically evolved to reflect the adaptations. What's like what will be the new conditions after this if the adaptations happens. And then based on this evolved like that model, we have to perform some runtime assessment and then figure it out like how the adaptation impacts this security profile assurance. So the first challenge is how we can represent, how we can abstract the system's internal structure and like that how they are connected to the security requirements and complying the, and how can we assure that the systems is actually complying with the security controls or the security requirements. So the goal-based, like I use the goal-based modeling approach, and currently it is very popular in the assurance case researcher community, like this researcher communities, and then I also use the assurance case structure to like that express and like abstract the system's internal structure and connected the security requirements and provided the evidence that how it can comply with those requirements. So this structured process or the modeling process is called assurance case, and since I am dealing with only the security requirements, that's why it's called it's called the security assurance case. And assurance case has the, like we will see in the after some slides like that how assurance case actually look like. It provides the it shows the dependencies like and connect that how the security requirements or the security goal are connected with the internal components, and then how it is connected to like the provided the evidence that systems is complying with those requirements. And it is kind of like the explicit representation, so easy to follow by any stakeholders. You don't need to be expert to understand the assurance case. Like even the business people can also understand and they can pinpoint. And since it's a graphical representation, it's easy to track like that, easy to like the pinpoint and track down. And it also has the ability to pinpoint the context and provide the justifications of the requirements implementations. So the graphical representation standard I have used is goal structuring notations to design my assurance case. Usually this, like the novelty of my work is that the assurance case is kind of like documented from. It was not automated, but for my research, I implemented one framework. I designed one framework, and that has the ability to like that instantiate some assurance case model automatically by getting some parameters well. Why we need this like that automated process? Because as I said, that assurance like model needs to be dynamically evolved and then like that to reflect the adaptations conditions. So we handle by doing the automation process, we handle the evolution challenge, and then to handle the uncertain situation. So I developed a framework. This is like the template from of one of the on assurance case. Like the rectangle is representing the goal or the security or the requirements, and then the parallelogram is for the which components are supporting to like the comply with those requirements, and then the circle is the evidence which connect with the with some analysis components showing that like that the systems is complying, like the component is good enough to comply with those security requirements. And then the eclipse are for providing the what is the operational context of why we need these security requirements and everything. And you can also extend this assurance case model as like, and also abstract it as per your requirement your preferences, and that's what the module component is doing. And in the like if you look at the template in the curly braces, these are the parameters. By getting this parameters value, it will instantiate automatically the what should be my security requirements or the security goals, and what component is dedicated for complying with those requirements, and what should be the assessment or the analysis like that tasks to provide the evidence that the systems is complying with those requirements. So goal structuring notations is already kind of like the rich enough that like it can express or the represent like the assurance, like represent every component for providing the assurance case. But we also figure it out, there are some like security, as you know, like we will see that, but like as you know that like the security requirements are not standalone. Like there is not only one security requirements, or our security requirements has interdependency with other security requirements, like, and also other functional requirements. So we need to provide that, like they show the interdependency or interrelationship among different security goals. So we have to like augmentate the security, like the goal structuring notations to support that representations. And we did that and supported the automations. As I was saying that like security requirements is not standalone. There will be like if and also like when systems has multiple security requirements, they have interdependencies. So we like not only showing the assurance case for only one security requirements, we also need to show that like that network of how they are connected, and how impact on one security requirements has like that negative impact on the other security requirements as well. So we like along with developing the templates, we also develop like to represent the security control network, and that we call the security control network or SCN. And from this like from this network, like we when the adaptations impacted one security requirements, and how like, and the fast assessment will be like how it impacts just one security requirements, and then the next assessment will be like how it impacts the entire network. And then based on this entire network, we'll figure it out that what should be the best optimal adaptation solution for the situation. So the first challenge we address is like we develop a template, and then have some like that process to instantiate it, and by getting the parameters value, and also have a process to like that represent the interrelationship among the security controls of the, and generate a security control network. So now the next challenge is how we evolve the model when the adaptations change, like when the adaptation has the potential to change the goals of the functionality, right? So we need a component that like that will support the dynamic evaluation of the security profiles to reflect the adaptations. So there are some model management techniques, and then some researchers are actually deploy like that all possible adaptation situations, and then they generate like that assurance cases, and then just instantiate it like whatever is more relevant to this situations. But that is not the solutions, right? Because like we cannot predict that what should be the adaptation. So we need actually some operator that will read like that will like the figure when we get to the adaptation representations, those operator will dynamically changes the model and make the model like that evolved in according to the adaptation changes. So for this reason, like I develop an adaptation operator manager that supports for like right now 3 types of operators. And though like one operator is called like change file, that is only like when the adaptations just changing, tweaking some like the parameters value. So those operators will just make the changes. It's not internally the system structure is same, just some parameters value has been changed. that in that situations, the change while operator will be instantiated and then evolve the model. The other two types are like the support or and substitute operator. Support is like that when adaptations actually like introduces a new functionality to continue the existing functionality, that time the support operator will be instantiated, and the substitute operator is for when the adaptations changes the entire functionality, like to like the entire existing functionality, that time like that we substitute the existing functionality with the new functionality, that time like substitute operator will be instantiated. And those operators are instantiated based on the what type of adaptations has been chosen, not by any human involvement. So for instantiating those operators and make the evaluation, so we need what is the adaptations, right? Like when systems figure it out, this is my adaptation, and then it has to represent accordingly so that the model can be evolved. So we I defined a structured representation for like how the adaptations look like, and then representation is called change set. It has some parameters value, and it was actually set of some tuples, and based on those tuples values, like it will instantiate it one or multiple operators to like that evolve the model. So we got representation, we got evaluations, but now we need to like why we are doing these things. We are doing these things for assessment, right? So the next challenge is how can we assess, like what type of matrices we need to like that provide that, and we need some quantitative value to figure it out, like that to make the final decision that this is a good adaptations for my systems to continue the operation. And obviously those matrices will be calculated at runtime and then determine how the adaptations impacts the security profile assurance. So we called it the confidence value is the degree of confidence, because it is not providing the systems is 100% confident, this much confident. It is provided that it could be like that the probability of the being like the good, the confidence of the probability of how confident the systems is to comply with those requirements. So we define two assurances matrices. First one is achievement weight. This achievement weight is all working on one single security requirements on one single assurance case. As I said that if you remember the previous, we have a network of security controls, right? But at first we have to figure it out like how these adaptations impact each single assurance, each single security controls. And then when you figure it out, each single security controls has been impacted that way by using the achievement weight. And then we have to figure it out like if the achievement weight changes for this like one security control, how it impacts the other security controls. And that assessment has been done by satisficing level. It estimates the degree of confidence in security compliance for all the security control goals within the security control network. So the final result will be like the final decision will be made based on the satisficing level, not achievement weight. For calculating satisficing level, we need achievement weight to figure out how individual security controls will be impacted, and then the satisficing level will be like the entire systems will be impacted. And based on this satisficing level value, then finally we'll figure it out these adaptations could be the optimal solutions to continue with functional requirements and then comply with the security controls. So we develop the developer framework that has the ability to instantiate the system's internal structure in a goal structuring notation format, and then it has the ability to instantiate an operator to evolve the model, and then it also has the ability to do the assessment. But where like self-adaptive systems is the big systems, like where I should employ this framework to like that perform these operations to figure it out. So usually like the self-adaptive systems or any autonomous systems is kind of like that has embedded like that map loop, or we can call it the monitor, analyze, plan and execute loop. It is a like the for feedback loop and like and a continuous it performs continuously. So in the monitor phase, it will collect the environmental conditions value, just doing the monitoring the systems and the environment. And analyze phase is like it will figure it out like that the systems is like do we need adapt, like based on the situations, collected values, it will figure it out that systems is behaving accordingly or has some deviations or not, so that we need adaptations or not. And in the planning phase, we have to figure it out that this is my situations and this could be my adaptations, and then we need to perform the assessment that like which one will be my most appropriate adaptations for continuing these operations. And then the execute phase, we just enable that adaptation. So what do you think, like where should I employ my assessment framework in this 4 phase in the loop? So it should be in the planning phase actually, because like in the planning phase, based on the based on the adaptations, it makes the decisions like what will be my most appropriate adaptations. So it needs to do the like that, take the adaptations representations and perform the assessment. So my like this is the like kind of elaborate format of this map loop. And actually this blue box is my adaptation assessment framework. So in the monitor phase, we will just set some props to like collect the values. And I evaluated these systems in 3 different applications. So we just have for the monitoring phase, we just have some like that process to collect the values. And then the analyze phase is just some testing that the systems is behaving accordingly. And then the finally plan phase is like it takes the representations, evolve it, do the perform the assessment and figure out this could be my most appropriate adaptations for these situations. And then in the execute phase, it just enable that adaptation component. So what is the advantage of having this adaptation assessment framework? So the advantages is like when you don't need to like define some predefined rule for like that these could be my adaptations and perform the assessment accordingly. It can take any dynamically configured adaptations as long as you can provide the change set for the operator. It will dynamically evolve the model and then perform the assessment. And currently it is in the planning phase, but we will extend this work to like that for the execute phase, but it has limitations, obviously. So the limitation is that like, as I'm saying that like adaptations choice, like when it makes the adaptation, perform the assessment, it's actually need to understand like that what is my context. I was not actually dealing with those context part. Like I was dealing with that this is my adaptations and perform the impact like that, and provided the calculated impact value and then choose the best possible adaptations. But the impact could be defined based on which context the system is actually operating. So same adaptations can have different impact for different types of context. We need to interpret that environment. Currently, these uncertain conditions are like that. It was kind of those uncertain conditions are predefined. We provided those things, and then the framework will just assess accordingly. But in the dynamic environment, it's not possible that we know the all possible uncertainties, and that's where the explainable AI part will come. Like explainable AI will provide some now they will provide the interpretations that why the model is making this decision based on the probability value of some attributes conditions, and those we need some translator to take those interpretations values and then make more clear idea about like this what is the uncertain conditions. And currently I am moving forward to these directions, but like right now I don't have actually enough data or enough result to show you people, but hopefully in future I can show some work in this field. But like we figured out that explainable will be the AI will be the potential like the potential solution to interpret the uncertain social conditions. And this will be my like that current research work, but like that in near future, not only those explainable AI part, I also want to like that you like that develop the plugin architecture for this adaptation assessment framework, so that we don't need to level up the assessment framework for each single self-adaptive systems. We can just plug in accordingly. So for doing these things, we need to standardize the format to like that share and interpret data, handle the communications, define some protocols, and also define some semantics to formalizations. And also like to make the communications more effective among the MAP loop, we need some protocols. I will work on that. And for doing these things, we also need to handle some metadata to support the MAP loop activities. It will be my future research work, but currently I am actually more focused to the applications of explainable AI, but I don't have data. And so for there are some peer-reviewed paper like on my adaptation assessment framework work. And so for this is my presentations, but I am happy to answer any of your questions. And yeah, there is like a lot more going on in the assessment part, but I skipped because like it will be too much detail to discuss. But like I am happy to answer these questions, and we have answer time.
Thank you, Dr. Sharmin, for your wonderful and insightful talk. Now I'd like to open the floor to my dear audience to ask any question by the raise of hands.
Can I ask, please?
Yeah, sure.
Yeah, sure.
Okay. Okay. Thank you, Dr. Sharmin, for your wonderful presentation. Can you please go to page number 23?
Yeah.
Yes. Here you told something about MAPE loop. MAPE, monitor, analyze, plan, and then execute. And you told that in the planning stage, you will assess the adaptation operators. Okay. Then my question is, for example, if there is multiple adaptation operators and we have to assess them, and then the best one will be implemented. So my question is, in the planning stage, do you assess and then implement both, or you just assess them and figure out the best one and then you implement that?
Actually, like that adaptations plan comes from like externally, or it will be pre-implemented into the system. So there are multiple adaptations that are already deployed, or somehow like it has defined source. In the planning phase, you have to find out that which one is, because like as I said previously, like systems should have the self-knowledge, like what is its ability. Like I cannot choose any adaptations that I cannot actually deploy, right? So the adaptation should be there. So multiple choice of adaptations are already there deployed in the systems. Now I have to find out what is my best adaptations for the situation. In the planning phase, we do the assessment of the multiple choices of adaptations and find out that these could be the best solutions, and then just enable that components to like add in the execute phase to figure out like that, deploy the adaptations into the system.
Okay, thank you. I got my answer. Thank you so much.
Any more question?
Okay, I have few questions regarding these cases. Is a system a black box system? My next question is, as I've seen in the presentation, most of these works is heavily based on optimization problems, which in many cases doesn't have any solution. How the system tackles those cases, and how the adaptations operator are defined in case of all the adversary situation. And none, those are my questions, really.
It's black box to the like it depends on the which type of a stakeholder you are, but like that there should be some administrative people, like for those peoples it was not black box, but mostly it's a black box. Yeah, that's why we need those assessment components and then the assurance case model and dynamically evolve itself, because like there is no one sitting there to like that to figure it out like what's going on in the systems, and then there is actually not possible. So that's why we need the self-awareness ability. And yeah, it cannot actually handle all possible solutions.
Is there any possibility that it will go rogue?
Yes, that's why the assessment things, like, because like the adaptations can be like introduces new vulnerabilities, like it introduces like the more risks than the like better than like that shut down the systems. Yeah, it has the possibilities, and that's why like that. But that's why we need to do the assessment to figure out like what how much confidence the systems should be to still continue those requirements, or like that those requirements. And if we could not find out any adaptations, in that case maybe the fail-safe plan is like just quarantine or the shut down the systems. And
Okay.
but like, yeah, if you are not careful enough and your assessment components is not strong enough, it will choose some adaptations that introduces more risks than the break down the systems. And
Okay, that will be all my questions. And is there any raise of hand among the audience? And unfortunately, I see none. And with this, I'd like to conclude today's webinar. Thank you, Miss Dr. Sharmin, for this wonderful talk. And we hope to hear in the near future from you. And
yeah,
thank you
thank you
all
so much.
for attending today's webinar. And with this, I conclude today's ceremony.
Yeah. Have a good day. Good night, actually. Bye.